My name is Eduardo. I work on the Union team, and today we're going to talk about raw containers in exotic languages. Your mileage may vary, what people think of exotic might not be so exotic to others, so let's do it. Quick recap on what raw containers are, how powerful they are, how we use it. Talk a little bit about, exotic languages, show a demo, and then we do Q&A. So raw containers, to me, they look like this. They're like jet engines with all the wires exposed. It's like a Swiss Army knife. Like you are on your own, but it's very, very, very powerful. Like you can run literally arbitrary containers. This means like anything from Alpine to like the most carefully crafted, image that uses like Haskell if you want. In the backend, we do all the work to map, inputs and outputs. So it's not like a fire and forget thing. Like you can actually pass data to and from raw containers, and orchestrating them is super, super easy. They look like this. This is copied from the documentation. Here, just defining a raw container named Square that will read its inputs from this locally mapped in like from the data volume that Flyte maps in the container when the container starts from this directory /var/inputs. Similarly, we do the same thing to outputs, and from the outside, like to actually pass data in, you pass this dictionary. Here we have a single input of type int, but don't get too hung up on this. This could be like complex objects like protobufs or dictionaries. Similar to outputs, same idea. You have a dictionary of named values where you can refer to them afterwards. In this particular case, we're using the Alpine image, and here's the command that's gonna run when this task runs. It's a simple shell script that just multiplies the input, like the val that you pass in. It writes to this location, the /var/outputs/out. It's like it's a file that takes the result of echo the multiplication, right? And from the orchestration point of view, like in Flyte-kit, this is how you use it. Like we have a container task, we name it Square. We have a task here, it's called sum, just to complete the picture. It literally just like copy adds to integers. But the interesting bit here is the workflow. See how we are consuming the Square function or the Square task, and it just looks like any other task that you define in Python. Now let's talk a little bit about languages. Like last time I checked, we have 10,000 languages, 10,000 programming languages. How crazy is that? So I picked a very small, short sliver of this, and just to show how to use raw containers with these 5. A shell script, just like the example that we saw, it's just a little bit more complicated. Python, of all languages, why do I consider this as an exotic language for this demo? Like the feature that I want to emphasize here is that you can run any version of Python that you want. Let's say you have some code that only runs in Python 2. Go for it. It's fine. You want to use a different Python implementation, like not C Python, like maybe it's PyPy or some other ad hoc Python runtime that you want to run. Like go for it. R is, I think it has a bigger presence in academia, but I just want to show like how to use R. And Haskell is very dear to my heart. Like in a previous life, I wrote a bunch of Haskell. I just want to show how to use it, like what are the problems and how they compare to like the other language that we have. And Julia is the new kid in the block. A lot of people think that Julia will be the next Python for data science / machine learning. I just wanted to show how to use it. So I picked a very simple problem that would allow me to exercise, some of the common problems that you have to solve anyways if you wanted to use raw containers with any language. So it's program that just outputs the area of an ellipse. You take, A and B floats, and it spits out the another float, which is just like the pi times A times B. Not super important. Also, some metadata, like in our case, we're just like we're gonna spit back a bunch of strings just to show that you can work with more complex types. So real quick, let's jump to a demo. Do you still see my screen? Oops. Do you see like two like a code editor or no? Yes?
We see the code editor and your slide deck.
That is amazing. So let's do this. Great. Move this guy. Great. So here's the complete demo. Here I'm just like, actually let me increase the font. This is good. Is it okay? Cool. I try to be super dedicated with this example. I wrote down. I did not generalize. I just wanted to show how it would look like to run a bunch of raw containers in different languages using like the same example, right? So calculating the area of the ellipse. So here's how the code looks for how to kick off a shell script raw container. If you squint, like it is literally the same to run Python minus like the actual command that you run, but they all look very similar. Like you have an executable that points to the file, and then you map the inputs and outputs. So for R, it is super similar to like you have R script points to a file, and I say, hey, read this stuff from /var a/inputs, similar for outputs, and same for Haskell, same for Julia. Let me just show how the actual code for the shells. Oops, I have to increase a little bit. And this is reading this file called A from the input directory, similar to B. It's just like calculating pi times A times B. Shell script doesn't have a pi, so I had to do some math here. This is 4 times the arctangent of 1. It's fine, and it writes the result of that to this file, which is /var/output/area, and here I'm just outputting some metadata, like, hey, I'm writing this script or this string to this other file. Okay, here's how the same code looks in Python. Oops. Very similar. Get the inputs, calculate the area, write the outputs to a bunch of files. Now let's take a look at how the Haskell one looks like. Very, very similar to, read the inputs, calculate the area, write the file. And finally, Julia. Yeah, Julia has a bunch of, I learned a little bit writing this example. So in Julia, we can have like Unicode variables. So pi can actually be spelled out as pi. It's crazy. And in order to handle command line args, you have this special, keyword called args in Julia. But the code is literally the same. Read the inputs, calculate the area, and write the output to a bunch of files. Let's go back to the workflow. So the workflow that orchestrates this whole thing, it just kicks off the raw containers for each one of the languages. Here again, I did not generalize this. Like I just wanted to be like super like explicit. Hey, just run these, and at some point, I'm just reporting so that we can see that the containers ran and whatnot. So let's go now to the, oops, not question, the demo. This is not important. So we have the Lips metadata workflow. Let's just run it with, I don't know, 3.1 and 4.2. Takes about 20 seconds to run. Maybe. Just one thing to note, we did not talk about how raw containers run. This is totally outside of the scope of this talk. If you were interested, to know about the design of Copilot, like there's a doc that Keaton wrote some time ago, and there's a PR they issue. You can, Anyways, here's we have a very simple. Let's just start from the graph. Have all the raw containers running parallel. They all report the data to this single task. And in terms of like how the task looks like, they're very much the same. So like this is the shell node. See like how the Python node looks like, or looks the same for the Haskell one or the Julia. And just to show that I'm not lying, take a look at the logs. So the report here, there's like, these are the 5 important log lines, right? This is just reporting the value returned by each language. And I don't know if you can see this, but the precision, it's not the same across the languages, which it's curious. But anyways, yeah, that's pretty much it. Does anyone have any questions? Again, I just wanted to show how raw containers could be used. They all faced similar problems, like you need to handle inputs and outputs. For the shell case, Keaton just introduced a new task type for this release called shell task. For anyone out there running complex shell scripts, please use shell task. But otherwise, go this route. Wire the thing yourself. It's all good and super powerful.
Yeah, the idea for raw containers was like we cannot write SDKs for every language or every version of the language and so on. So thank you for bringing that up, Eduardo. And you don't have to write SDK for every language, because the other thing that we realize is that most business logic exists in one language or the other. And then you always sprinkle in some other random languages for random things. Like Perl is still probably the best at handling string. So maybe, I don't know if anybody uses it anymore, but you could.
Yeah. Or Fortran or whatever, like people do math stuff with Fortran these days still. Sorry, this was a bit rushed, but does anyone have any questions?
All right. Thank you, everybody, for joining. It was a wonderful session today. Hopefully, we'll have more of these awesome sessions in the new year. But there's one more, December 14th. I know some folks cannot join this session, so I'm going to talk to Gojek team. They want to present like their usage of Flyte and so on. But I don't know if they'll be able to attend. So please, we'll keep you posted. Thank you for joining today, and look forward to seeing you again.